Welcome to the Transum Podcast, a monthly roundup of the new features on the transum.org website, providing mathematical puzzles, games, learning activities, and the ever-popular mathematics lesson starter of the day. Here's your host, John Tranter.
Well, my heart is still thumping. I've just been downstairs. There's a big hairy spider out of the back window, and on the front drive, believe it or not, there is a snake. Getting on for a metre long? Well, it's actually quite a long snake, but very thin. It's only about as thin as a pencil. But nevertheless, there is a snake on the front drive. So I'm inside, doors closed, recording this podcast for the month of May 2021. And this is podcast number 78. So let's get going with the puzzle of the month. In triangle ABC, the angle at A is half of the mean of the angles at B and C. So the angle at A is half the average of B and C. So what you have to do is find the size of the angle at A, and the answer will be at the end of this podcast. So now let me tell you about all the new things that have appeared on the Transum website over the last month, and the links to them all can be found in the newsletter, transum.org/newsletter. So, first of all, yesterday I just finished and uploaded the new Transformations Help video. And it actually turned out to be 45 minutes long, which is a bit on the long side. But the idea is it's to help pupils do the transformations exercise, which has 7 levels. So roughly, I guess, 6 minutes per level. So I'd only expect pupils to watch the excerpt that refers to the level they're doing at the time. So 6 minutes watching a video, maybe that's not too bad. Anyway, that's in the transformations exercise. Now, an additional level has been added to the Pythagoras' theorem exercise. And this new level contains Dr. Colin Foster's favourite Pythagoras tasks. Now, Colin is the Mathematical Association President Designate, and he gave a wonderful keynote address at the recent Mathematical Association 150th Anniversary Conference. And so he's got some good Pythagoras tasks which are at the end now of the exercise online. And another conference speaker, Mr. Southern Maths, gave me permission to use his coordinate geometry table on the website. So this challenge is to find elegant, efficient ways to fill in the gaps of the table, all to do with straight line graphs and the coordinates that of points that lie on those graphs and the midpoints and the gradients, and you get the idea. So that's called coordinate geometry table, and remember the links to all these things are in the newsletter, or you could just go and search for them with a little search engine that's on the website, or you could go into the topics page or the curriculum page. There's lots of ways to find what you want. A new set of exercises on finding the area and perimeter of parallelograms has been added to the site, with quite a challenging final question for the top level, which brings home the fact that sometimes areas can be found without using the formulas, but using, other problem-solving techniques. So, can you solve it? Have a go at that. That's the last question in the last level of the area and perimeter of a parallelogram exercises. Transum subscriber Anne Roberts requested a set of exercises on polynomial division, which I created this last month. But I decided that level 5 should be a really difficult challenge. So I revived an exercise from a book written in the 19th century. So it's a huge exercise of very difficult polynomial division questions. And Anne, bless her, has been doing a great job checking the answers of this marathon of a maths exercise. Anyway, in doing all of this, I learnt for the first time that traditional long division is not necessarily the best way to solve this sort of question. And an alternate method is provided with a video in the Help tab by Beth, who she's now studying at Oxford, but she was previously a student of Lucy, and Lucy was a former colleague of mine, so that's how I know about Beth. And so her method in her video is the one that I found actually easier to solve some of the more tricky questions.
You can find Transum Mathematics at www.transum.org.
If then trigonometry, that's the title, is it's not a big resource, it's just one exercise, but it asks the sort of questions, if the sine of an angle is 1/2, what is the cosine of the angle? That sort of thing. And it makes a nice companion to the common trig ratios exercises, which are all intended to be done without using a calculator. So that's up there live now, as well as an exercise called Make Them Right. It's a drag and drop activity, and you have to sort the given lengths into Pythagorean triples and place them by the sides of the right-angled triangles to make valid right-angled triangles according to Pythagoras' theorem. So it's sort of using Pythagoras' theorem backwards. Normally we use it to find the length of a missing side. Well, here you're given all of the sides, and you just have to show that you're putting them together in groups of 3 that do actually make right-angled triangles. So I used a bit of artistic license here, and in big letters I've said that the diagrams are not to scale, so I've had to make all the right-angled triangles the same size, because if I'd scaled them it would have just made the activity too easy. So anyway, a bit of artistic license there, hope you like that. Okay, a bit of fun. Groups of 4, it's a fun diversion based on the groups challenge of the TV program Only Connect. The Transum version is based on mathematical concepts, obviously, and it does get a little tricky when you get to level 6. In fact, at the time of recording this, I can see that 8 times as many people have claimed a trophy for level 1 as have claimed a trophy for level 6. So maybe the range of difficulty is just right there. It's easy at the beginning and then really challenging at the end, with every different level in between to suit everyone. Have a go at that. Another working backwards exercise I've called deconstructing graphs, because normally we get pupils to create tables of values and then plot the points to make graphs. Well, this is just the opposite. The graphs have been given and the pupils have to deduce what the coordinates of the key points are and put them into a table. So that's a nice little twist on normal activities. There are algebraic graphs, there's a scatter graph, and there's a cumulative frequency graph too. Okay, what else? I adapted the areas investigation, and that's been on the website for a long time, to produce a similar one called Try Dots. It's a challenge to find all the triangles that can be found by joining dots on a 3x3 grid of dots. And I was reminded of this challenge by another great conference talk, this time given by Colleen Young. So that's up there, ready for you to have a go at when you're ready. Okay, so while I'm remaining in the house this morning due to said spider and snake, neither wearing a mask, I may add. Anyway, while I was in the house, I was interviewed for the Math Mindset podcast. The interview took place over Zoom with me here in Thailand and the host, Maura Olo, in New Jersey, USA. Now, as the time difference was almost 12 hours, I deduced that we were on opposite sides of the world. Well, ignoring sort of latitude differences. And first of all, I just am so impressed with technology these days. I mean, the video was so clear and the sound was so good. I'm old enough to remember poor quality and high cost of long-distance telephone calls not so long ago, so that was wonderful. Anyway, towards the end of the podcast, I told the tale of the mysterious missing pound, which I skillfully converted to dollars. And, well, it went like this.
Is there a favorite puzzle or challenge that you've noticed on the website, or a few that are more popular than the others?
Well, one of my favourites, actually, I mean, you may have heard this before, but I'll tell you again, is the story of the three ladies that go into a Thai restaurant for lunch. And the bill comes to $30. So each of the ladies pays $10.
Are you writing this down?
No, you don't need to write it down.
Okay.
Each of the ladies pays $10 towards this $30 bill, and the waiter takes the money to the cashier, and the cashier said, "No, you've got it wrong. The bill should only have been $25. So the waiter comes back with $5 change. But the waiter can't figure out how to share the $5 between the three ladies. So he gives them $1 back each and keeps $2 for himself. So the three ladies, how much have they paid now? They paid 10, they had $1 back, so they've each paid $9, correct? So 3 9s are 27, plus the $2 that the waiter keeps makes 29? Where did the extra dollar go? Have you heard that before?
I think I should have written it down. Oh, that's a good one.
Yeah? Okay, well, the answer is, here's the answer for all the people listening that want to know the answer. Later that evening, 2 men go into that same restaurant for dinner. And their bill also comes to $30. So they pay $15 each. And the waiter takes the $30 to the cashier. And the cashier says, "No, you've got it wrong. It was only $25. Here, take $5 change to those 2 gentlemen." So the waiter's coming back with the $5, but can't decide how to share the $5 between 2 people. So he gives them $1 back each and keeps $3 himself. So now those 2 men originally paid $15, have had $1 change, so they've paid $14 each. 14 and 14 is 28, plus the 3 the waiter kept is 31. That's where the extra dollar went. Now, the answer to the puzzle of the month. There are many ways to think of the situation, but, well, I guess the easiest is an algebraic solution, as with many of these. So I use the letters A, B and C to represent the size of the angles, and of course A, B and C must add up to 180 because they're angles in a triangle. So the mean of angles B and C is of course B add C, all divided by 2. So half of that is B add C divided by 4. And we know that that is equal to A. So what I did is I just rearranged that equation to make B plus C the subject. So B plus C equals 4A. And then I substituted that B plus C into the angle sum of a triangle equation, which gave me 5A equals 180, so that A was equal to 36. And I've written out this solution in the newsletter, transom.org/newsletter. You can see it there. But anyway, the angle is 36 degrees. And B and C could be anything really. Well, they could be any positive values, and of course they have to sum to 144. So yeah, B and C could have many different values, but A is definitely 36. Okay, that's all for now. Look after yourself, and if you can, look after someone else too. Bye.
Thank you for downloading and listening to the Transom podcast. You can find the website at www.transom.org, where you're welcome to use all of the activities absolutely free, or jump in with both feet and become a Transom subscriber.